Alright, so hello everyone, I'm Nayak. We are in our playlist of summarizing trees advanced topics. Right now, currently in our topic which is segment trees. Before we start, if you want to learn this topic in a good depth, you can go through this video which was taken by Striver on segment trees, or you can go through this playlist by going code. Both the playlist and the link and the videos link will be in the description. You can find it out. So the first thing is that what kind of problems do we use segment trees in? This is basically the range query problems. Basically, if you are given an array and then I give you a range, two indexes, and I ask you to find a minimum between that range, or the sum between that range, or a XOR between that range, or something else between a particular range. To do this in a most efficient manner, we use segment trees. And also, like, suppose I change a particular index and then ask you to find the whole minimum or the maximum or XOR, alright? So for this kind of problems, we use segment trees. Segment trees is basically can be divided into three major parts, which is build a tree, find in a tree, and update a tree. By build a tree, I mean converting this into a tree is the first thing which we'll be doing, and then finding the value in our range is basically find in tree is finding the minimum in the range, or the whichever thing is required in the range, and then updating a particular value at the index. All right, so let's start with the first, which is build a tree. Building a tree basically means dividing the given array into segments, into small segments till we get a single value. All right, so right over here we have a array. This is the array of given range as 0 to 5. The start index is 0 and the end index is 5. The size of the array is 6. All right. So if you see, what I'm doing is we are dividing this whole range into small parts, which is 0 to 5, the whole thing, and then it is divided into two parts, 0 to 2, this much, and then 3 to 5. And then again, this 0 to 2 is divided into two parts, which is 0 to 1 and 2 and 2. This and this. Again, this is divided into two parts, which is 0 and 1, and this is 2 only. Okay, and similarly over here we divide the whole thing into smallest parts. Obviously we cannot divide this single thing into other part, that's why we are not dividing, we are stopping over here. Okay, so why are we dividing this into small parts? It is basically because we want to store the minimum or the required thing in this and then giving it to the parent. Alright, so our question is for this, which I'll be explaining, is finding the minimum value in a range. Alright, and then you can temper the template which I'll be giving you for segment 3 to find other things like sum or XOR or anything. Okay, so for 0 and 0, what is the minimum value? If I give you this range, just this much, if I give it will be 1, right? Because there is nothing else to give, therefore it is 1. For 1 and 1, it is 3. For 2 and 2, if I give you the range 2 and 2, it will be 2. Similarly, for 3 and 3, it will be 0. For 4 and 4, it will be, okay, 4 and 4, it will be 4. And for 5 and 5, it will be 5. Okay, good. Now, for the range, this 0 to 1. Okay, so for 0 to 1, what I'll be doing is I'll be taking the minimum of these two. Okay, minimum of these two, which is 1 in this case, and over here I'll be taking the minimum of these two, which will be 0. So this is how recursively I will keep on coming up to the root of the tree, and the root will have the minimum of the whole array. Alright, so for 0 to 2 I will have the minimum as 1. For if you do not even look here, you can solve it from here. For 0 to 5, 3 to 4 and 5 to 5, I combine, which is 3 to 5, I will have the minimum as 0. The minimum of the children, the minimum of the children now here is 0. Alright, so this is how we build a tree, which is keeping the minimum in each and every segment. Okay, in the segments which we have divided the array into. Not get scared by looking at the things on the left hand. On the right hand, if you see, this is basically what I just showed you, right? In that notepad, basically keeping on the values minimums. Alright, so what is happening here is, why are these numbers written? It is because what we want to do is we want to store this value somewhere, right? Like for 0 to 0 at some index or some place we want to store. One thing we can do is we can create a map of there and then store the values. Rather, we just create an array to store the values, which is more suitable for us. So this is seen like if we have a whole, a binary tree, complete binary tree also, to store the values most efficiently without exceeding. 4n is the value of the array that we create. It has a very big proof. We do not want to get into it. So just understand that you need to create an array of 4n, and at every index we start with 0 to 6, okay, 0 to 5 actually, 0 to 5, and then with the index 0 we keep its value at index 0 and the other children's value at index, which is for this case 0 into 2 plus 1 and 0 into 2 plus 2 at 1 and 2. For 2 we keep at 5 and 6, because 2 into 2 4 plus 1 5 plus 2 6. Alright, let me just show you the code so it will be easier for you to understand. Okay, so this is the thing. If you do not understand C++ or don't understand OOPS or something, do not worry, the code is really simple. I will just explain it. So firstly, you have a nums, in which I give an array. I give an array of size 6. I hope it's visible. Yeah, of size 6. This is what I'm giving right now. And to build a tree. So build a tree has firstly the node, the start and the end. Okay, node is this index at top, which is 0, and then 0 and 5, which is start and end. Okay, if the start is equal to n, basically these leaf conditions, then just keep that node's value as nums dot that particular index, which is for suppose 1 comma 1, it will be nums of 1, which is 3. All right, so this is the thing. Or else what I'm doing is I am finding the mid value. Mid value means for 0 to 5 actually. So the mid value will be 0 plus 5 by 2, which is 2. So 0 to 2, and I'm going for 3 to 5, basically like this. Start to mid, and then mid plus 1 to end. And the indexes of those where I'll be storing them are these, which is written here, right? Index into 2 plus 1, index into 2 plus 2. So those will have these index to store the values. And then my node's value will be min of these two values which will be stored. Okay, this is how we are actually storing the array, storing the segment tree. Right, so finding the tree, let us consider a segment in the array we had, which is 2 to 5. I suppose this is the segment that we want to find. This was the array, right? So from 2 to 5, it would be 2, 0, 4, 5, right? Indexer. So now what we do is we, for all the cases, we only have 3 options. Firstly, no overlap. Secondly, complete overlap, and partial overlap. See, no overlap means if we want something from index 2 to 5, so if we have a segment from 0 to 1, so it will be nothing of our use, right? So it will be no overlap. Complete overlap means suppose we have this segment and there is a segment with 2 to 4, so it is completely inside of it. All right, or suppose that is complete overlap, or suppose one other option is 1, 2, 3 is there, and then our segment is this. So there is some amount of, here we have 2, right? 2 to 5. So there is some amount of overlap. So partial overlap is there. All right. These are the 3 cases. So let us start with the first one, which is 0 to 5. So some amount of it is inside of it, which is 2 to 5. Not the whole thing, but some amount of it is inside of here. So we will break. For this condition, we will break into 2 parts. We break, we go to a left, we go to a right. And similar to the building the tree, we have the mid as well. So from 0 to 2, we have one segment here. From 3 to 5, we have other segment over here. So 0 to 2 is again a partial overlap because 2 is the overlapping index. All right, overlapping segment. Now again for this one, we will go to the left and the right. So if you clearly see over here, 0 to 1 is a no overlap condition for this required. So we just return something which is very much related to the answer. Like if you are finding the minimum, so we will return here int max. Int max. All right. And for this one, if you see, this is a complete overlap condition. This is overlapping completely because 2 and 2 is completely inside of it. So it will return 2, the answer it has. And now we will update this value. This value will be updated. Or if we want, we just take this segment's value and we go to a right and take this segment's value, which is 0 in this case. 3 and 5 will be completely overlapping. So 0 is returned from here. So the answer is the minimum of 0 and 2, which is 0. All right. So this is also summarized over here on this one. If you want, you can read it, or this is the code. First one was building the tree. I guess you're clear with that. Second is this one. We are given a query range. This is the start and the end of the segment, and this is the required left and right. All right. So what we are doing is, if it is completely outside, the no overlap condition is here. If the start is right of is even more than the right, all right, so it is completely outside. Like if we had 2 and 5 and there was a segment of 6 to 7, or there was a segment for 0 and 1. So it is completely outside. So just return long max for our case, or if it was a sum problem, we will just return 0 or something, right? I mean 0 only. And now the second condition is, suppose it is a complete overlap. Like for this condition, 2 to 5, 2 to 2 was a complete overlap and 3 to 5 was a complete overlap. All right, so just return the value at that node, which is 2 and 0. And then the last thing is, suppose you have mid, and okay, suppose you have a partial overlap, so we will just divide it. So like this, we will find the mid and then ask for the value from query range, start to mid, and then mid plus 1 to end, and we'll get the minimum and we'll return it above. All right, so this is how simple it is. So in the third case, we have, suppose we are given an array like this, 1, 3, 2, 0, 4, 5, and in the segment we want to update a particular value. All right, so for example, we want to update this value at index 2 to 0. Then what will be the answer? for this the answer will be the same 0 only, like for the whole array, but for the sub array it will change, right? So for that reason, or like suppose for this one we had like we were given this array and then we wanted to update the index 3 to 10. After that, for all the ranges, we want to effectively find the minimum value in each and every range, or the ranges they will ask us. Alright, so in this one, if you see, suppose we want to update this value to 0. Let's consider that example. Firstly, to do that, we need to find the index where we want to change index. Alright, let me write this. Index is equal to start of the segment, and the start is equal to end. This is the requirement. In this whole tree, we will try to find that only. Alright, so for this one, if we divide it into two parts, the mid would be 2. And so for one, we will move, for in the left side, we will move from 0 to 2. And on the right side, we will move from 3 to 5, right? So for this condition, we do not want to go on the right, we'll just go on the left. And now if we see, the mid would be 1 over here. So on the left, we'll be moving from 0 to 1. And on the right, we'll move from 2 to 2. So we'll move here on the right, we won't move here, we'll just move on the right. And if you see, right now, the index is equal to start, which is 2, and the start is equal to end. That means we reach the leaf position. We need to update this to 0 and revert back here by updating this to the minimum of left and right, which is 0 for this condition because we updated it. And then we will again revert it here, that on from the left side you are getting 0. From the right side you already were getting something, we didn't calculate it again. We'll have that value stored. So from here also we are getting 0, so the answer will be 0 ultimately for the whole array. But for this one it exceeded, right? So if I have to show you the code for this one, if I want to update a particular node's value to the new value, alright, and then we have the start and index and the new value, we'll firstly traverse the whole thing. Okay, for actually if you observe, the start and end will be same if we do like this. Firstly we will find the mid for each condition, and then if the index is less than equal to mid, so we are moving to the left side basically like this. Or if the index is greater than mid, like we had the mid as 2, if there was 3 or something, we'll be moving on the right, right? So this is moving left and right. And then if we move somewhere, if we were moving like this, and we will encounter the correct value only, so that time only the start and end will be equal. If you want, you can write this as well. Start is equal to idx, and this same thing. If you observe the code, you will understand we do not have to write this. And then it will update this value, and as you update this value, the parent will take the already pre-calculated value for this and the updated value for this, like this, minimum of the left child's value and the right child's value. This is how you will update it. Alright, I hope this is clear. Okay, so now let's do one thing. Let's use our template to run the code. Actually, I will make you understand this segmentTree template. But first, let me explain the input format. Firstly, this is the size of the array that we are taking, and this is the whole array 1 3 2 0 4 5. And the question is, we need to find they will be given 2 queries. For the first query, you will be given a range, and you need to find the minimum in that range. And the second type of query is you are updating a particular index with a value. Alright, so firstly this is the you took the input for the array, the vector, and then the number of queries, and this is the first each query will have 3 numbers. First will represent the type of query. Suppose the type of query is 1, so then the second value is the lower range and the third value is the upper range. If the type of query is 2, then this is the index and this is the updated value for that index. Alright, so let's run this code. Yeah, so if you carefully observe, for 0 to 2 the minimum value is 1, right? From 1 to 2 for 2 to 5, which is basically this, the minimum value is 0, so 0 is getting printed. Now we updated the second index to 0. This is updated to 0. Alright, so again I am asking the first query, which is I want the minimum from 0 to 2. Now it is giving us 0 because the second index is now 0. Now we are updating 2 values. We are updating the second index to 5 and the third index to 5. So these two became 5. So now I am asking for this array, which is the minimum value, which is 3 5 5 4 5. So the minimum is 3. So we are getting the correct value. Alright. So basically in this segmentTree template, I explained you the build tree and then the query and then the update value, and it is simple. We just give the vector over here to the segment and then ask for the query. It gives us the minimum value. And suppose you were given a different type of question, you do not have to find the minimum value, you just wanted to find the sum in that range. Alright, so what will you do? Like over here we were finding the minimum, you would have just added these two values to get the answer, to show the answer in the tree. Alright, so you just need to update this segment tree to the way you want. according to the question, and the answers will be in front of you. Yeah, easily, like most effectively. I'll be giving the school in my GitHub as well, and the link will be in the description.